Modern periodic table. Before starting the lecture, click on the subscribe button and get access to our 100 of unique conceptual lectures for free. Firstly, let me quickly revive the Mendeleev's periodic table which we have learned in the previous lecture. We know that in the Mendeleev's periodic table, elements are arranged on the basis of increasing atomic masses. For example, the atomic mass of hydrogen is 1.01. The atomic mass of lithium is 6.94. So Mendeleev Baba firstly placed hydrogen, secondly he placed lithium, and thirdly he placed beryllium. Thus noted down that in the Mendeleev's periodic table, elements are arranged on the basis of increasing atomic masses. Later, when new elements were discovered, like noble gases or isotopes of different elements, it was difficult to place them in the Mendeleev's periodic table. So then scientists formed modern periodic table. It was British scientist Henry Moseley who formed the modern periodic table. He found something very interesting. He observed that elements are periodic function of atomic numbers. He called this as a modern periodic law, which you will learn in this lecture. For example, consider first 18 elements of the modern periodic table. Now Moseley Baba placed elements according to increasing atomic numbers. Atomic number means the total number of protons present in an atom. The atomic number of hydrogen is 1, so he placed it as the first element of the modern periodic table. The atomic number of helium is 2, it is placed second. The atomic number of lithium is 3, so it is placed third. The atomic number of beryllium is 4, so it is placed fourth. Hence, by this way, he placed elements in the modern periodic table. Now, what is the main difference between Mendeleev's periodic table and modern periodic table? Well, Mendeleev Baba arranged elements on the basis of increasing atomic masses, while in the modern periodic table, elements are arranged on the basis of increasing atomic numbers. Also, we will study some other parameters of modern periodic table. For instance, why Moseley Baba didn't place helium just after hydrogen and placed it here? Or why we have such a strange shape of modern periodic table? Well, Moseley Baba ensured that elements with same chemical properties should be placed together in one group. Noted down that chemical properties depends upon the number of electrons in valence shell. For example, consider the group 1 elements like hydrogen, lithium and sodium. The atomic number of hydrogen is 1, the atomic number of lithium is 3 and the atomic number of sodium is 11. We know that the atomic number is equal to the total number of protons or the total number of electrons. So the electronic configuration of hydrogen is 1, the electronic configuration of lithium is 2,1 and the electronic configuration of sodium is 2,8,1. We can see that these three elements have same number of electrons or 1 electron in the outermost shells. So they also have same chemical properties. Thus Moseley Baba placed these 3 elements in the same group or first group. Secondly, consider the group 2 elements like beryllium, magnesium and calcium. The atomic number of beryllium is 4, the atomic number of magnesium is 12 and the atomic number of calcium is 20. The electronic configuration of magnesium is 2,8,2 and the electronic configuration of calcium is 2,8,8,2. We can see that these 3 elements have same number of electrons or 2 electron in the outermost shells. So they also have same chemical properties. Thus Moseley Baba placed these 3 elements in the same group or second group. Similarly, helium is placed in this group because helium has same chemical properties as neon or argon has. Therefore, remember that Mosley Baba placed elements in the same group having same chemical properties or same outermost electrons. Finally, we got this type of modern periodic table. Do you know that why these two rows are placed at the bottom of modern periodic table? Here, elements in this row come after lanthanum because the atomic number of cerium is 58 and that of lanthanum is 57. So it is named as a lanthanide series. Similarly, elements in this row comes after actinum, so this row is called actinide series. Now you may be thinking that why the elements of lanthanide series aren't placed after lanthanum and elements of actinide series aren't placed after actinum. Well, it is because these elements have different properties. For example, these elements are rare earth elements. Secondly, they are radioactive elements, and also they are known as the inner transition elements. Thus, due to these properties, they are placed at the bottom of the modern periodic table. Finally, let me discuss the achievements of the modern periodic table. Firstly, metals are separated from non-metals. For example, at this side, all these elements are metals, and at this side, all these elements are non-metals. Secondly, hydrogen is accurately placed in the modern periodic table. Thirdly, isotopes of different elements are correctly placed in the modern periodic table. Fourthly, we can easily predict the chemical properties of elements by knowing its group. I hope that you have learned all about the modern periodic table.